Good afternoon, students. Today we are going to discuss the topic, the overlay networks in distributed file system. Yeah, this overlay network is a virtual network of nodes and logical links that is built on the top of existing network with the purpose of to implement a network service that is not available in the existing network. See in the diagram, see this is a physical network below and the overlay network above. When this overlay network comes into the picture means an overlay network is the virtual network of nodes that is also consisting of nodes and logical links that is built on the top of the existing network with the purpose of implementing a network service that is not available in the existing network. In this case, we are calling a overlay network. Coming to the internet is an overlay network. The main goal of this overlay network is connect the local area networks. Second one is built on local area networks, that is on Ethernet and phone lines, and add an internet protocol header to all packets. Okay, this is about the internet is an overlay network. See, this is the clear picture of overlay network and physical network. The physical network, the overlay network is above the physical network, which is consisting of nodes. See here, Skype is the example. Skype as overlay network. All we know about Skype, right? Skype is an application that provides video chat and voice call services. And the Skype is available for Microsoft Windows, Macintosh, or Linux, as well as Android, BlackBerry, and both Apple and Windows smartphones and tablets as well. This will be available on all these categories. And the Skype allows the users to communicate over the internet by voice using a microphone, by video using a webcam, as well as with instant messaging. Okay, instant messaging by using instant messaging, and video by using webcam, voice by using a microphone. This is the usage of Skype. Here, the Skype to Skype calls to other users are free of charge. Here, the Skype to Skype calling is free. Coming to the Skype architecture, the Skype is an overlay peer-to-peer network. Why we are discussing about the Skype means, the Skype is the example of an overlay peer-to-peer network. There are two types of nodes in the overlay network, that is ordinary host and super host or super nodes, SN, that is called as red SN or SH, super nodes or super hosts. An ordinary host is a Skype application that can be used to place voice calls and send text messages. Okay, an ordinary message is a Skype application that can be used to place voice calls and send text messages. Coming to the super node, SN, it is a node. Super node is an ordinary host. Ordinary host's endpoint on the Skype network. Super node is the ordinary host's endpoint on the Skype network. Any node with the public IP address, any node with the public IP address having sufficient CPU, memory, and network bandwidth is a candidate to become the super node. Okay, any node with public IP address, a node with a public IP address and having sufficient CPU, memory, and network bandwidth is a candidate to become a super node. This is the information about the ordinary host and super node. Skype peer-to-peer call telephony protocol. See, the green color ones are here the ordinary hosts. This is the super node, and this is the neighboring relationships. Here, see, this is for one super node, one super node and several ordinary nodes are connected to the super node. Here also same. Here Skype login server. This is the Skype login server. Message exchange with login server during login. Okay. From Skype login server, ordinary hosts will send the request, and ordinary host will get a reply from the Skype login server. This is a peer-to-peer internet telephony protocol. See, here the ordinary host must connect to super node. See here in the diagram, the green colored one are ordinary hosts which are connected to super node and must register itself with the Skype login server for a successful login. Okay. Second one, the Skype login server is an important entity in the Skype network. The Skype login server is an important entity. This is the Skype login server. It is an important entity in the Skype network. Where usernames and passwords are stored at login server. Usernames and passwords are stored at Skype login server. Here, user authentication at login is also done at this server. User authentication at Skype login server, they will ask to enter our username and password. This user authentication at login server is also done by server. Here, this server ensures that Skype login names are unique across the Skype namespace. See, this server ensures that the Skype login names are unique. Okay? This is unique, and this will across the Skype namespace. Coming to the protocol. Here we are using a protocol VoIP, that is voice over internet protocol. Skype uses a proprietary internet telephony network called as Skype Protocol. This is one type of voice over internet protocol. Here, the protocol has not been made publicly available by Skype, and official applications using the protocol are closed source. Here, the main source between the Skype and standard VoIP clients is that Skype operates on peer-to-peer model. Okay, here we have seen this is a peer-to-peer model. Here, the protocol, the main difference between Skype and standard VoIP clients is Skype operates on peer-to-peer model rather than client-server model. See here, normal VoIP uses a client-server model. Here here Skype uses which type of model? Peer-to-peer model. Skype operates on peer-to-peer model, and the VoIP clients uses client-server model. Okay. Next topic is routing overlays. Here, this routing overlay is a distributed algorithm for middleware layer responsible for routing requests from any client to host that holds the object to which the other request is addressed. Okay. This routing overlay is a distributed algorithm for a middleware layer. Okay, we know the middleware is in between the operating system and user applications. In the middleware layer, responsible for routing requests from any client to host that holds the object to which the request is addressed. And it is responsible for locating the nodes and objects. Routing overlay is responsible for locating the nodes and objects, and it implements a routing mechanism in the application layer. And it ensures that any node can access any object by routing each request through a sequence of nodes. Here, this routing overlay will ensure that any node can access any object by routing each request through a sequence of nodes. Okay. Here, the peer-to-peer systems usually store multiple replicas of objects to ensure availability. Here, the peer-to-peer systems which uses store multiple replicas. Replica is nothing but same information is stored at multiple places, multiple replicas of objects to ensure the availability. Okay. In that case, the routing overlay maintains the knowledge of location of all available replicas. Here, the routing overlay mechanism knows the information of the replicas and deliver the request to the nearest live node. That is one that has not failed, that has a copy of relevant object. Why? Because all will store the replicas. So it is storing the copy of the relevant object data. Next, by using GUID, global unique identifier used to identify the nodes and objects. Here, these are also known as opaque identifiers. These are also known as opaque identifiers since they reveal nothing about the locations of the objects to which they refer. Okay. Here, the two methods. One is to GUID, global unique identifier, which is used to identify the nodes and objects, and these are also known as opaque identifiers. Next, assigning GUID. Peers are assigned to a GUID when they can join an existing network. See, any node enters into the existing network, we need to assign the GUIDs. So here, the peers are assigned to a GUID when they enters into the network. Here, coming to the main task of routing overlay is routing of requests to objects. Why? Here the request is always for access the object, right? Here, the routing of requests to object is a client wishing to invoke an operation on an object submits a request including the object's GUID to the routing overlay. In the other models, what they will do, they will give, if any client wants to access the object in the server, it will forward the request to the server. Here in this routing overlays, any client wishing to invoke an operation on an object submit the request including the object's global identification number, object's global unique identification, unique ID to the routing overlay. In the earlier cases, the request is given to the server. Here the request is given to the routing overlay, which routes the request to the routing overlay. This routing overlay will route the request to a node at which the replica of the object resides. Why? Because here in this we are maintaining the replicas at different places. Here the routing overlay routes the request to a node which replica of object is containing. Here coming to the routing overlay, this will also perform the following tasks. Those are insertion of objects. Here, a node wishing to make a new object available to a peer-to-peer service computes the GUID for the object and announces it to the routing overlay, which then ensures that object is reachable by all other clients. That is insertion of objects. Okay, here whenever a new object is available to a peer-to-peer service, first it needs to computes the a GUID for the object and announces it to the routing overlay. Deletion of objects. Here, the client requests for the removal of any object from the service. The routing overlay must take them unavailable. Okay. Upon the client request, here the routing overlay must take in the action against the objects, and those will be unavailable. Next, node addition and removal. Here, Nodes or computers may join and leave the service. When a node joins the service, the routing overlay arranges for it to assume some of the responsibilities of other nodes when a node leaves. See here the load balancing is very important. See here the node addition and removal. Here, if any new node added to the network, if any node added removed from the network, we need to load the balance. We need to balance the load among the all nodes in the network. Here we are having two types of overlays. One is unstructured and second one is structured overlays. Coming to the unstructured systems, these are do not impose any structure on overlay networks or are loosely constructed. Example is Napster, BitTorrent, eDonkey, and these will support complex search-based file metadata and low search efficiency, especially for unpopular files. Okay, this is unstructured systems. It will take it will give us less efficiency. Coming to the structured systems, here these will impose a particular structures on the overlay networks. Example is distributed hash tables. Example is distributed hash table. The topology of the peer network is tightly controlled. Here, any file can be located in a small number of overlay hops. The structured overlays use a number of different geometries, that is rings, trees, hypercubes, etc. These are two types. One is unstructured overlay and structured overlay. Types of routing overlays. Here we are having DHT type, that is distributed hash tables. In this we are having methods put GUID, value, get GUID. Next, second one is DOLR, that is distributed object location and routing. This will uses the methods publish GUID and publish GUID. This will know the location of the object and routing information. DOLR is a layer over the DHT, that is distributed hash table. DOLR is a layer over the distributed hash table DHT that maps the GUIDs and addresses of the nodes. That maps the GUIDs and addresses of the nodes. This is all about overlays. Okay. As of now, we have discussed about overlay network. Okay. This is overlay networks. In the overlay network, first we have this what is overlay network and the diagram. The example is Skype. The Skype as overlay network and the Skype architecture we have seen here. And after that, this is the information about the Skype architecture. After that, this is a protocol. In this protocol, we have seen the differences between the VoIP protocol in the Skype and the peer-to-peer model we have seen discussed here. After that, we have started the routing overlays. In this routing overlays, we are having what is the major task of the routing overlay, and the tasks performed by routing overlay are the insertion of objects, deletion of objects, node addition and removal. And after that, two types of overlays. One is structured overlay and the second one is unstructured overlays. Okay. This is the types of routing overlays, majorly having three types: DHT, that is a distributed hash table. Second one is DOLR, that is distributed object location and routing. Okay.